Hello and welcome to episode 12 of Fumbling with C#. In the last episode we did the agent grid, so we can now see agents that are checking into the team server. And we added this little counter style last check-in. We also created this context menu. So the idea is that clicking interact will open up a tab down here in the TabControl view. So in this episode we're going to work on two types of tabs. We're going to do a tab for the event log. So that will be global server type logs like users logging in and logging off. And we'll do a tab for an agent view. So the first view we'll do is the event log view. So we'll create a new user control and call it event log view. And a corresponding event log view model. So in the event view, I'm just going to have a simple list view, and we're going to bind that view to a property that we'll just call event logs. And we'll have them displayed in a little data grid. So we'll have a grid view and we'll define the columns. So we have a grid view column, the header, the first one will be time, and the display member binding will be event time. So if we have a look at the server events that we're consuming here, each server event has a time, a type, and just some associated data. These are the types at the moment. So in the event log view, we'll have users logging on and logging off, initial agent check-ins, and when modules are registered. Probably move that out to the agent event, although it might already be in there, so it might be in there twice. So this will be the event time. You can see how the view is starting to form up here again. The event type, and let's call this event data. So this will be type and data. Now, in terms of like widths, you can't do like star like you could with, you know, like a grid view or something, or just a grid. So we can't really do this. So for now, I'm just gonna stick some static values in. Now, even though a view has a height and a width, and this width is 800, you can see we're exceeding that. Actually, when you embed the view into a window that is bigger, it will fill the space. It shouldn't get cut off. So we should just get a list of events as they come in here. So then on the event view model, we'll create that property for the events, and this will be an observable collection of server events. And what do I call the binding? Event logs. Now I'll create a constructor. And I'm just going to do the same sort of thing that we did here. So we're going to kick off a thread, and we will initialize these properties. So this will be a new observable server event. Logs and the lock. This can be get server event data. And so we need to create the API. So I'll call this server API. And it's very similar to this. So I can just copy. And this will be a task list of server event, get server events, and the endpoint for this, as we can see in Swagger, is API server events. Like so. So here we can do server API, get server events, and we're going to do the same kind of thing. So we'll do if the event logs already contain the events, or if they don't contain the events, then we'll add them. Otherwise, we will just not do anything. So we'll say these are server events. So for each EV, you can't put event because that's a keyword. That's what we want is, so E represents an event already in this collection. So we'll say if there are any events in the collection that have a time that equals this new event, and the type, and the data. We could just say, we could just check the event time, right? And we can say, we can make an assumption that there's only ever going to be one event at one point in time. But I don't really know how accurate the date timestamp is coming over the API. So if we're just checking an event time, then we might not include events that we should. We could even expand that to say, well, we may only expect a particular, what are the chances of having 2 events of the same type at the same time, and only check those 2 things. But let's just check all 3. So what are the chances of having two events of the same type that contain the same data at the same time, which is probably not going to happen. The only thing is I don't know how computationally intense this check is, so we'll just have to see how that performance goes. So the event, come on, time is time, the event type is the event type, and the data is the data. Now we should be doing it like this. Data. I'm not really sure about that because now we're going to be recreating the event time in this constructor. So we might have to revise how these are structured. Hopefully that's all that's required on the view model, and the view should be okay. So now on the main view model, we have to create a new tab item and add it to the tabs of the tab control on the main window. Now the main window has the tab control, but we're not binding to anything yet. So let's bind the item source, and let's just call it tab items. And on the main view model, we'll create an observable collection of type tab item. So a tab is a tab item, and what do I call it? Just tab items. So let's initialize that here. Okay, now the event log window we want to create as soon as that window opens. So we can do that in the constructor. So we can create a new method to do that. So we'll call it a private void add event log tab. So the tab is a new tab item. The header, we can just call it event log or event logs. The content will be a new event log view, and the data context will be a new event log view model. And then we add that tab to the collection and call it within the constructor. So where should we do that? Let's just do it at the end. Okay, and let's give that a go. Okay, so we can see the tab is created, but it's not actually active. If I click it, and we get a whole bunch of events. But you can see actually that it's creating them every second, so our little check thing doesn't really work. And we're also missing the data. And I would also like it in a different order. So this is like first, and then we're going like down in time here. But I'd like the most recent ones to appear at the top. So let's have a look at what's going on here. So instead of add, we can do insert. And instead of creating this new event, we can actually just pass in EV. So add will always add something to the end of the list or the end of the collection. Insert, you can actually insert at a particular index. So 0 will always insert it at the front. So doing that whole new server event, blah, 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 was a big mistake. Could have just passed in the event from here. Although we still don't have any data, so. But you can see that it's only, we've only run once. So the reason why we don't have any data is probably the binding. So this field is just called data. And oh God. And I think I called the binding something else. So I called it event data, and it's actually just data. Okay, that's much better. So you can see a user logon called raster, and that was me in Swagger to start the listener. Now the listeners don't raise events yet, which is why there's no event for starting a listener. And then we have the initial agent checking, which is this agent up here. And you can see how I've made it so it displays the user identity at their IP address and the host name. This is obviously a local user. If this was a domain user, then the domain would be here. And then we have all of our user log-on and log-offs for Neo, which is me opening and closing this client all the time. So the reason why I think that it doesn't select the tab by default is that we just create the tab and that's it. The UI is not like selecting the tab. You know, selecting an active tab. So I think we can do that in the view model. The TabControl has, as well as item source, it has a bindings for selected item. So that will be a particular tab item. So the main view model will know which is the active tab, whether it's an event log tab or an agent tab. And it also has selected index. And we'll bind this to selected tab index. And on the view model we can have it is an int selected tab index. So if we put a breakpoint here, we'll just step through this method of initializing the view and the view model, and then we add it to the collection, and then we come out. So we're just about to come out of the constructor. And the window hasn't opened yet, hasn't rendered, and the selected tab index is actually 0. Oh, what? I was not expecting that. And this time it just popped in, so that's interesting. So I think there's a bit of a race condition. So whenever you have multiple tabs, when you click a new tab item in the background, I think probably what the framework is doing is raising one of those notify property changes that tells the UI to refresh and show the new tab. When we create a new tab in the constructor, we may be raising that notify property change on a window that doesn't actually exist yet. And so what we need to happen is we need this window, we need this view to render in fully before raising the property change to make sure that this tab is being displayed. Maybe that's a problem for another day. But you can kind of see how working with user interfaces is a completely different kettle of fish, really, to just console applications. Okay, so it seems to be relatively happy. We'll just keep that as it is for now. So let's move on to do this interact functionality here. So that menu, it's in the main window, right? Here. So we need to bind a command to this, and we'll call it agent interact. And on the view model, we can copy the iCommand stuff that we've got on the login window. So we'll call this agent interact. Agent interact. And in the constructor, agent interact is a new delegate command for on agent interact. And this will be quite similar to this, right? All we need to do is add a tab, so we can say var tab, it's a new tab item. The header, we can set it to anything we like, really. I think Cobalt Strike has them as IP address and a process ID. I think we can just stick for the agent ID for now. But where are we going to get the agent ID from? Don't know yet. The content will be a new agent view, and the data context will be a new agent sort of view model. So let's create those. So the view, we'll call it an agent tab view, or maybe just agent interact view. Agent interact view model. Okay, so I'll just leave those blank for now and just say content is a new agent interact view. And the data context will be a new agent interact view model. We'll then do tab items dot add tab. And this model will almost certainly need an instance of the agent, which will pass in on the constructor for the view model. And just say agent is agent. In the view model, we need to get an instance of this agent. And we can do that off... Why does that keep popping out? It's so annoying. We can do that on the main window view. So the data grid, like the TabControl has different types of bindings for the selected items, so does the data grid. So the data grid has a selected item, and so we'll bind that to selected agent. And on the view model, it will be an instance of agent, selected agent. And then so we can just pass in selected agent like so, and reference the ID of it. So let's see what that does. So let's right click and interact. So we can see it create the tab, and it has the agent ID as the header, but by default it doesn't then select the tab, right? Which will be quite useful. It'll be useful to make this the active tab as soon as we interact with it. If we do interact again, then we're just going to create multiple tabs. So a check to see if the tab is already in the collection would also be pretty good. And the view is not showing anything at the moment, so there's nothing to see. Okay, so maybe we can say something like, if tab items any, oops. So if there are any tab items that have a header that are equal to the agent ID, then we can just return. Otherwise we can do this. Let's try that. So that's one, and trying to do it again doesn't do anything. So that's good. Maybe we can revise this just to say just to do it like that perhaps. And then we can explicitly set the tab index. Now the thing about the tab index is that, again, this is another thing that we have to trigger a notify property changed. And I don't necessarily want to have each of my view models inheriting from iNotify property changed. So what we'll do is we'll create a new view model and we'll call it base view model. And the base view model can inherit from iNotify property changed instead. And we can just copy this code from the agent. We can also make the agent inherit from base view model, but because this isn't a view model, it doesn't make a whole lot of sense to have this inherit from a view model when this is not a view model. And so we can just put this method here and make it public. And then if we make this inherit from the base view model, we can do this private int selected tab index. On the getter, we'll return the selected tab index. And on the setter, the selected tab index equals the value, and then we can just call this notify property changed method on the base view model and just call it selected tab index. Do you need an extra closing brace? So to set the tab index, we now need to know which index this tab has in this collection. Now you can make an assumption maybe and say that add will always add it to the end, so we can just get the length of the collection and just use that. Or we can get the explicit index of by saying maybe something like tab items index of. Maybe we can just say tab here. Not sure. We'll find out. Nope. Oh, that's selected. What is my keyboard doing? Selected tab index equals. That was what I actually meant to do. So there you go. Now when we interact with it, we set it as the active tab. Okay, pretty cool. So let's go back to the actual view. So for now, what I actually will do is just copy what's in the event log view, I think. Just to show. And we'll call this binding agent events. And an agent event it's actually here, has a time, an event type. So I've got module registered, yeah, so I have got module registered here, an agent ID and some data. So we don't need to display the agent ID, we just need to display the time, the type and the data. In the view model, we'll be just repeating the same thing again. So instead of like the application having a core view or a view model that gets all of the information, each little view is responsible for fetching the information that it requires. That does mean that the application is going to be running quite a few threads. So in this API, we'll just copy this method. So there's another API endpoint here to get agent events, and it just takes a specific agent ID. So if we pop this in here and say execute, there's one event so far, and that's the module registered for the core agent module. And then this is the URL format. So we can just, in here, feed in an agent ID and just pop it in the URL here. And having the same method name is fine. It just creates an additional overload option. So we'll get agent data, and we can say that the agent ID is just off the agent model here. And we can just steal this method. So we'll need a new property, and this will be an observable collection of agent events. We'll set the binding option. And initialize it. Events. And the lock object. This will take in an agent ID. And to get agent data in Visual Studio, it now shows you an additional optional overload, so we can run it without a parameter or with a parameter. So we'll obviously be running it with a parameter. And this where thing is oops. So, same thing. Let's copy that line from the event log view model. I think this is going to be pretty similar. Using link. This will be agent, although just easier to rename that to EV, I think. Oh, I need to change this. So this will be an agent event. Not session data, so that's now fine. And we'll do agent events, add EV. Okay, so a lot of sort of copy pasting. I hope a lot of this makes sense. Okay, let's see what happens now. Oh, there we go. So we can't issue any commands from this yet. In the next episode, what we'll do is we'll add, in this agent views, we'll add a little text box down here so we can type stuff in and start interacting with the agent. For now, we can do it on the on Swagger. Let's issue a command. We'll say core, let's say sleep, and the JSON string it expects is interval and jitter. So there we go, we can see the command request appeared with the data that was submitted. And again, this is ordered kind of like top to bottom, so maybe I'd like to flip that as well. So what we'll also need is some means of closing these tabs. So these are stuck open at the moment. Another thing is if we are like off this tab and we say interact, it won't add a new tab, but it would be cool if it just made this tab active. A couple of those things we'll do at the beginning of the next episode, and then we'll crack on with the text box and stuff. And you can see the actual sleep time has changed as well, so that's cool. Thanks for watching everyone, and I'll see you in the next one.